Welcome back. In our last activity, we used bar models to model fraction division. In this activity, we're going to use number lines to model fraction division. And our first goal is to determine how many quarter-inch pieces are there in 3/4 of an inch. You could probably use a ruler to figure this out and just count how many quarter inches fit into 3/4 of an inch. Well, here we have an example that uses a number line to answer this question. This length right here is 1 inch, 0 to 1. That would be 1 inch. And then right here we have 3/4 of an inch. So how many quarters fit into that? 1, 2, 3. There are 3/4 in 3/4 of an inch. That makes sense, doesn't it? So that's just an illustration of number line models and how simple they are and how they can help us do fraction division. Because the question we answered right there is 3/4 divided by 1/4. And we can clearly see why the answer is 3. Now let's see if we can use that same clarity to look at some more complicated fraction division. Before we move on, let's go ahead and answer these questions. What is the quotient? The quotient is 3. Then what does that mean? It means that there are 3 1/4 inch pieces in 3/4 of an inch. Write a question to describe what each division expression is asking. Then draw a model to determine the quotient. Write a sentence to describe your answer. Let's do the first one together. A question that I might write here would be, how many 1/8 inch pieces fit into 1/2 of an inch? So how many 1/8 inches are there in 1/2 of an inch? Let's draw a number line to figure it out. First, I'm going to start by showing where 1/2 is on my number line. And then I want to divide this into eighths of an inch. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so these are my 1/8 inch pieces. How many of them fit into 1/2 inch? Let's see, 1, 2, 3, 4. So if I was going to answer with a sentence, I would say there are 4 1/8 inch pieces in 1/2 inch. Cool. So it's pretty easy to use a number line to represent that. That's my example. I want you to pause the video and work with a partner for let's change this to 4 minutes. Let's keep it at 4 minutes. Work with a partner for 4 minutes to finish exercise B. You've hit play, so you must be ready to talk about it. I divided my number line into eighths. I marked where 3/4 belonged, and then I boxed in groups of 3/8. 2 groups of 3/8 fit into 3/4. Next, you're going to work with your partner to create a model to represent each situation. We've got a variety of situations to work on here. For each of these situations, we have number 3, number 4, and number 5. You are going to create a model, and then you're going to answer the question. So you got 2 tasks. First, make a model. Next, answer the question. We're going to give you 3 minutes for each of these tasks. So that means altogether you have 9 minutes. So set a timer for 9 minutes. Pause the video. And at the end of 9 minutes, hit play. You've hit play. So that means you are ready to talk about these 3 questions, number 3, number 4, and number 5. So let's take a minute to do that. First, we had Mason. He had 2/3 of a foot of ribbon. We wanted to start out by drawing a number line. I have 0 and I have 1. And I'm going to go ahead and figure out where 2/3 would belong on there. Here we go. This is 2/3. Now he's going to divide the ribbon into 1/6 foot pieces, 1/6 of a foot piece. So let's see, that means I need to divide this into 6 sections. There we go, 1, 2, 3, 4, 5, 6 sections between 0 and 1. So that's how he's going to divide up that ribbon. We wonder how many 1/6 foot pieces can he fit into 2/3 of a foot? Okay, well, here's a 6. Here's a 6. Oh, hang on. Didn't draw that one very well. Here's a 6. And here's a 6. So he can fit 4 of those pieces into 2/3 of a foot. So we were able to use a number line model to answer a practical real-world question there. Could we do it with mixed numbers too? Sure we could. This time, instead of having my number line go from 0 to 1, I want it to go from 0 to 4.5. And then we want to divide the trail into sections that are 3/4 of a mile long. We wonder how many of those can we fit in there. So let me divide it first into fourths. Before I can divide it into fourths, I really need to divide it into whole numbers. That makes it a little bit easier. So then I'm going to add my halves. I already have 4.5. Here's 3.5, 2.5, 1.5, and then there's just 1/2. And then the values in between there will be fourths. So these purple marks denote fourths. There we go. Now we need a signpost at every 3/4. So let me get another color. And then every 3/4, we're going to need a signpost. So how many signposts did we need? We needed 1, 2, 3, 4, 5, 6 signposts. So that's 6 signposts or 6 sections. And we were able to do all of that just with a number line. Our first step was to find 4.5 on the number line. Then we divided the number line into fourths. And then we made a box around every 3/4 to show where we would be putting our signpost to divide up the sections of the trail. You guys did one more example, and I know you worked hard on this. Here, Aster has a board that's 3 1/3 feet long. So let's start by drawing our number line. Start at 0, and this time we're going to go up to 3 1/3. You know what might make it a little bit easier is actually putting my numbers down first, 0, 1, 2, 3, which means 3 1/3 will be right after 3. Now, she needs to cut the board into 5/12 pieces. That means I need to divide this into 12ths. Trust me, it's easier if we divide it into halves first. There's my halves. Okay. And then within each of those halves, I'll have 6 pieces. This is a lot of dividing it up. I'll zoom in to show you the detail. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now I have 6 sections on either side of that half. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sections. I want to do that for each one of these because we're going to be dividing it into 12ths. I'll pause the video so you don't have to watch me draw all my little marks. Whew, that was a lot of little marks. Now let's divide it into sections of 5. I'm going to have to zoom in again to do this. 1, 2, 3, 4, 5. Let me pause it again while I draw these. So how many pieces can Aster cut? She can cut 8. Now you saw, it took me a little while to draw all those marks and boxes, and it took you a little while to do all that too. So you're probably wondering now, what's the faster way to do this? How can I divide mixed numbers and fractions more efficiently? So this is a perfect time for us to transfer from a model to a procedure. We've drawn models to answer the question, how many groups of a certain size are in a number? In this activity, we need to analyze a few models that we drew to develop an efficient way to perform division of fractions without a model, because we don't just want to draw boxes all day long. So let's look at the strategy that we use to draw a model for 4 divided by 1/3 and 4 divided by 2/3. So remember, when we created the model 4 divided by 1/3, we partitioned 4 wholes to create 12 parts. So we divided that up into 12 parts. And so we found that 4 divided by 1/3 was equal to 12. We had 12 parts that were all equal to like 1/3. So notice there is one step to this process. Step 1, the denominator of the divisor is 3. Partition each whole into 1/3. This is the same as 4 times 3 is equal to 12. And remember, we kind of talked a little bit about that earlier when we noticed that when the numerator was 1, we could multiply 4 times the denominator of the number we were dividing by to get the answer. And that works here, doesn't it? 4 times the denominator is 12. And that happens to be the answer. That's that kind of interesting pattern that we noticed earlier. Let's see how that's related to what we do with 2/3. So here, what if we did 4 times 3? We would get 12, right? Well, then we would do 12 divided by 2 to arrive at 6. That's kind of what's going on here. So when we created the model 4 2/3, we divided it again into 1/3 parts, and then we grouped those parts together. That's why after we multiply 4 times 3 to get 12, we divide by 2, because we grouped all those little 1/3 parts into sections that were 2 parts each. Drawing those boxes is the part that was equivalent to dividing by 2. And that gave us 6. So when our numerator was 1, we were basically doing 4 times 3. When our numerator was 2, we just added an extra step. We did 4 times 3, and then we divided by 2. So this is how the process that we're going to use for fraction division connects to our model. We talked a little bit about this just a second ago. Here we said multiplying by the denominator gives us the same result as doing 4 divided by 1/3. So 4 times 3 equals 12 is equal to 4 divided by 1/3. Similarly here, we noticed that what we were really doing was multiplying 4 times 3 again, but then dividing by 2. And that's really the same thing as what we see here. 4 times 3 divided by 2. This is a rule that we can use for any division sentence's multiplication, but let's say it in a slightly simpler way. The easy way to remember it is that any division sentence can be rewritten as multiplication by taking the reciprocal of the divisor. Let's see that in action. It'll feel easier than it sounds. Here's some examples to take a look at, and I want to do these together. 5 divided by 1/4. You're probably thinking, Ms. Johnson, it's 20. I know it is because I know that 5 times 4 is 20. You're right. Here's why. What we're going to do is write 5 as 5 over 1, and we're going to multiply it not by 1/4, but by the reciprocal of 1/4. 4 over 1. That gives us 20 over 1, or 20, which is what you probably told me it would be, right? Because you recognized 5 times 4, that's 20. That's right, and what we're doing there is we're multiplying by the reciprocal. Remember that sort of wordy sentence we read a minute ago? That's what it said. It said that you can rewrite any division sentence as multiplication by taking the reciprocal of the divisor. To take the reciprocal just means that instead of dividing by 1/4, we multiplied by 4 over 1. That's what we did. So let's do that here. Here we have 1/8 divided by 2. I'm going to write 2 as 2 over 1 because it's not currently written as a ratio. So what would be the reciprocal of 2 over 1? It would be 1 over 2. Now we're ready to multiply. 1 times 1 is 1, and 8 times 2 is 16. The answer to this problem is 1 over 16. So what step did we use? We took the reciprocal of the divisor and then we multiplied. The reciprocal of 2 over 1 was 1 over 2. How about this one? The 4/5 is not going to change. That's our dividend. Now our divisor, we're going to use the reciprocal. Instead of 1 over 3, we'll use 3 over 1. And then we multiply. We multiply numerator times numerator and denominator times denominator. 4 times 3 is 12, and 5 times 1 is 5. This is a perfectly good answer. Some people prefer mixed numbers, and those people will want to write this as 2 2/5. Mathematically, both of these answers are correct because they both represent the same value. Now, before I just give away the answer to letter D, I know that you know everything you need in order to do this problem. We're going to keep the first fraction the same. We're going to multiply by the reciprocal. Pause the video and give it a try. You can do this one. You've hit play, so that means you're ready to talk about exercise D. What we're going to do is take our dividend and multiply it by the divisor, by the reciprocal of the divisor. So we're going to multiply it by 3 over 1. 3/10 times 3 over 1 is the same as 3 times 3 over 10 times 1. 9/10. It's easy, and we didn't even have to draw boxes and number lines. Now that you've got the hang of it, let's take a look at a mistake. Alexa is trying to think about reciprocals. She's trying to figure out reciprocals. Now let's review what we know about reciprocals. You guys know that a reciprocal is one of a pair of numbers whose product is 1. In other words, if I multiply two reciprocals together, I'll get 1. We used some reciprocals right here. So for example, we had 1/3 and 3 over 1. Check it out. This is why those two numbers are reciprocals. If I multiply 1/3 times 3 over 1, I get 3 over 3. That's 1. How about this one? Here we had reciprocals. We had 1/4 and 4 over 1. The same thing will happen if we multiply those together. 1/4 times 4 over 1 gives me 4 over 4. That's 1. That's why those are reciprocals. It works for all of these. We had 2 over 1 and 1 over 2. 2 over 1 times 1 over 2 equals 2 over 2, which equals 1. So 2 over 1 and 1 over 2 are reciprocals. That's what it means to be a reciprocal. Now, let's take a look at Alexa's work again. We want to help her figure out why she's incorrect. She thinks that the reciprocal of 3 and 8/5 is 3 and 5/8. Pause the video and talk with a partner about this. She's not right, and I want to see if you can figure out why. So I want you to pause the video and talk for 3 minutes. Hit play when you're ready to talk about it as a class. Okay, so let's explore, are these reciprocals? So some of you may have made the case that 8/5 and 5/8 are reciprocals. That is true. 8/5 and 5/8 are reciprocals. That's true. If I multiply them together, what will happen? Let's see. I'll get 40 over 40, and that's 1. But 3 and 5/8 is not the reciprocal of 3 and 8/5, and let's see why. To see why those are not reciprocals, what we have to do is multiply them together and see what we get. Let's investigate. 3 and 5/8 is the same thing as 3 times 5 plus 8 over 5. That's 15 plus 8, 23 over 8. Okay, next, let's do 3 and 5/8. That's 3 times 8 plus 5 over 8. Oops, did you see my mistake here? That's not supposed to be 23/8. That's supposed to be 23/5. Much better. Okay, now let's do this one. 3 times 8 is 24. 24 plus 5 is 29. This is where that denominator of 8 goes. I'm just going to check my work. 3 times 5 is 15. 15 plus 8 is 23. Yep. 3 times 8 is 24. 24 plus 5 is 29. Yep. Okay, so we've made both of these mixed numbers into improper fractions. So let's multiply them together and see if they equal 1. 23 over 5 times 29 over 8. That is equal to 667 over 40, and that is not equal to 1. So that is